हेलो स्टूडेंट्स। तो आज हम डिस्कस करेंगे 3D ज्योमेट्री। Like in two-dimensional geometry, we had x-axis and y-axis, and every point was represented as x comma y. Here we'll have three mutually perpendicular axes: x-axis, y-axis, and z-axis, which are analogous to your I cap, j cap, and k cap. The only thing is now the point is represented by x comma y comma z in this plane, where O is the standard origin, which is the intersection of all mutually perpendicular x-axis, y-axis, and z-axis. So if I join these two, you get your OP bar, which in vectors you are writing it as position vector of the point P, which is xi cap plus yj cap plus zk cap. That is equivalent to the R bar there is equivalent to the point P x comma y comma z in 3D. Therefore, this is one simple relation that can interconvert vector into 3D or 3D into vector. The point xyz is equivalent to the vector xi cap plus yj cap plus zk cap. Secondly, like in 2D, the both axes will divide the plane into four parts. Now in 3D, therefore they are called quadrants: quadrant 1, quadrant 2, quadrant 3, quadrant 4. One simple way to look at four quadrants is to write two ordered pairs with the same magnitude, but sign scheme can be plus minus plus minus. Two choices here, two choices here, 2 into 2 equal to 4 parts. This is plus plus, this is minus plus, and this is minus minus, and this is plus minus, right? Now in the similar way, now since there are three axes and each point is represented as an ordered triplet, so there will be plus minus plus minus plus minus 2 into 2 into 2, 8 parts. So three axes, basically three axes x, y, z, which are mutually perpendicular, of course, which are mutually perpendicular, will divide. Now it is no more a plane, it's a space, 3D space, into how many parts? 8 parts. So they are known as octants. 8 parts known as what? Octants. For example, first octant will be having the sign scheme plus plus plus. If you go in the order plus plus minus, then plus minus plus, okay, and then four sign scheme plus minus minus, and the contra, that is minus 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 plus minus plus minus minus plus plus. So these are the 8 possible positions, 8 octants. Okay, so when they say the point lies in first octant, analogous to first quadrant, all have plus 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 sign scheme. So you can also bifurcate like this that this is x-axis, positive x-axis, to be specifically this is negative x-axis, positive y-axis, negative y-axis, positive z-axis coming out of the plane, and negative z-axis going into the plane. So if the point lies in the plane formed by, say, plus x-axis, minus y-axis, minus z-axis, then the point is going to have plus minus minus sign scheme, etc., etc. Okay. Next, now since you know what is position vector of a point or coordinates of any point, suppose let me take one such point, call it as x1, y1, z1. This is your O, standard origin. There is another point Q, x2, y2, z2. Okay, call it as position vector as OQ bar. So now I am interested in what is PQ bar. PQ bar, using triangle of addition can be written as OQ bar minus OP bar, which is nothing but x2 minus x1 into I cap plus y2 minus y1 into j cap plus z2 minus z1 into k cap. And you know what does this magnitude of PQ represents? That is the distance between the points P and Q. This is nothing but magnitude of this vector, which is root over x2 minus x1 whole square, y2 minus y1 whole square, plus z2 minus z1 whole square. So it is an extended version of Euclidean distance formula in 2D. So therefore, if there is a point 1 0 minus 2 and there is another point minus 2 1 1, what is the distance between these 2 points? Simple formula is root over, call it as x1 y1 z1 x2 y2 z2, x2 minus x1 whole square, y2 minus y1 whole square, z2 minus z1 whole square. That is equal to 3 square and 3 square 9. So root 19. As soon as you see 2 points and distance formula, then immediately the thing we need to discuss is, look at this vector PQ bar. This is x2 minus x1 I cap, y2 minus y1 j cap, z2 minus z1 k cap. That is the projection of this, projection of PQ bar on x-axis is simply x2 minus x1. How? Remember projection formula PQ dot I cap by mod I cap. That is simply PQ dot I cap. Similarly, projection PROJ, projection of PQ bar on y-axis is equal to y2 minus y1. Similarly, projection of PQ bar on z-axis or in the direction of z-axis basically, that is z2 minus z1. So three components you can resolve which are parallel to x-axis, y-axis, z-axis. So based on this one simple question you can ask, planes are drawn parallel to coordinate plane through the points P x1 y1 z1 q x2 y2 z2. Find length of edges of parallelopiped so formed. So formed. So therefore, the thing is, so there is this point P, there is this point Q, for example. Okay. Okay. So you want to form a parallel piped, okay, by drawing planes parallel to these planes. Parallel to these planes. Suppose I draw something like this. And let me draw clearly here directly. So this is the direction of x-axis, y-axis, and z-axis. Let me keep P at origin, okay, and take this as Q, for example. Now let me want to draw planes parallel to them, x, y, and then z. Okay, so draw one plane parallel to this through P, and let me call this as my Q, the opposite edge. This is my Q, for example. Okay, and let me draw one more axis like this. Okay, now you see all are passing through this, and there is one more corner. So through this point we have done 1 2 3 planes. Through this point 1 2 3 planes. Yes, perfect. So now you want to see what are the edges of this particular parallelopipe. So what is this length? This length is nothing but, you see, if this is x2 y2 z2, This is my x-axis, this is my y-axis, this is my z-axis. You drop it, you drop it. That is, you bring this Q point into the plane of xz. Y coordinate will be 0, y coordinate 0. So it will be x2, 0 and z2. Let me draw here. So it's a first question. So it's like you have a parallel pipe in which all the plane faces, they are parallelograms, right? So you are marking the point P here, x1, y1, z1. So, but if you are taking this as x-axis, it can't be x1, y1. So basically, it is parallel to that. You can see. So here you take your x-axis, y-axis, and z-axis. So that we are not drawing here. Planes are drawn parallel to coordinate planes, not exactly the coordinate planes. So this is like y equal to y1 plane. So this is like, this is what? Y-axis x equal to 0, z equal to 0. So this is why then I have to write, see, when we write in 2D, equation of x-axis, it is y equal to 0, and equation of y-axis, x equal to 0, right? But in 3D, every line, this line for example, is intersection of this plane as well as this plane. This plane is formed by xz equal to 0. This plane is formed by xy equal to 0. So therefore, what is your x-axis equation? Y equal to 0 and z equal to 0. X not equal to 0 because x is varying here. So that is how you give equation of axis. That is equation of x-axis. How you write in 3D? Y equal to 0 and z equal to 0. Equation of y-axis. Each line axis is intersection of two planes. That means this itself is one plane. Y-axis x equal to 0 and by symmetry z equal to 0. Similarly, equation of z-axis means y equal to 0 and x equal to 0. So what if I write only one of these? That becomes plane. Equation of xy plane, z equal to 0. Every point will satisfy z equal to 0 in xy plane. Equation of yz plane, x equal to 0. Similarly, equation of xy, yz, xz plane. Equation of xz plane, y coordinate equal to 0. Then only it will come down to that particular plane. Therefore, so when I write equations here, I must write y equal to y1 as well as it is in the plane of, parallel to this, parallel to x and z. So this one, z equal to z1. So intersection of these two, this point is. So, so if you are assuming that QB is this, for example, x2, y2, z2, right? Now you have constructed this parallel pipe. So definitely this coordinate, suppose q dash, q dash. So that can be, will have same x coordinate x2 and the y coordinate is y1 and z coordinate is z1, right? You are bringing down to the plane of something parallel to xz plane, xz plane. So the y, so throughout this y shall be constant, that is y equal to y1. Okay, so similarly this point, this is like you have uplifted this in the direction of what axis? Y axis. So its y coordinate will change and that is y2 because these two are at the same height as you can see. So and z coordinate is again same, z equal to z1. So this axis, for example, you want to give the equation, in fact y-axis. So y-axis equation is x equal to x1. This is not y-axis, parallel to y-axis, and z equal to z1. This is the equation of this because this is equation of y-axis is x equal to 0, z equal to 0, but they are shifted. So parallel planes. So therefore, every point will satisfy this particular condition on this particular line. Similarly, this line z-axis is parallel to z-axis. Z-axis is y equal to 0, x equal to 0. So this will be shifted, y equal to y1, x equal to x1. So this point will have same y coordinate, x coordinate, but z coordinate is now shifted. So z coordinate, this point lies on same. uh, so if this is z1, I think you need to elongate this by these distances, call it as z2, call it as z2. So there seems to be some issue of this. These two should have, this is y equal to y1, y equal to z1, no, this is z axis, right? And I have shifted this cube, I have taken it here. Wait a minute. This one lies on same line. What is this line? A line parallel to y equal to y1. So this should be y equal to y2 line, not y equal to y1 line. So that seems to be the confusion. And coming back to, if you are calling this is z equal to z1, this should be z equal to z2. So therefore, ideally this should be z y2 z2. Coming back to the x coordinate, both shall have same x coordinate. Then how can these 2 points will have same coordinates? So let me rewrite all again. If it is drawn right here, it would be very easy. But it is like, see, it is like this is y equal to 0 and z equal to 0. So take by some unit, by shifting to some unit. So let me assume with respect to this system, this point is x1, y1, z1. And with respect to the same system, let me take 1, 2, 3 planes through this. And let me take this point as q, x2, y2, z2. So what is the meaning of this? The meaning of this is, until here it is x1 distance on the x-axis side, until here it is x2 distance. So this distance is going to be x2 minus x1. Okay. Similarly, y side, until here it is y1. If I drop a perpendicular, this is y1, and this is going to be, y2. So this difference is going to be y2 minus y1, this edge length. Similarly, z. So it is like you are going into the negative z side. That's okay. So until here it is z1, and until here it is z2. So this is going to be z2 minus z2. That is how you can give the edge lengths. Therefore, edge lengths of parallelopiped is going to be equal to x2 minus x1, y2 minus y1, z2 minus z1. And regarding the position of the vertices, see, we are saying this is P x1, y1, z1, and this is like on the same z. So they should have same z coordinate. So this point should have same z coordinate. Same z? No. Z axis. If this is z1, right? And this is z2 minus z2. So this should have z2. And coming back to here, yes, they should have same x coordinate and y coordinate. So that is your origin, interestingly, this point. And coming back to here, since you are elongated by x2 units, so this fellow should have coordinate x2 here, and yz are same because they lie on the same line. So this line is y equal to y1 and z equal to z1 line, and this line is going to be y equal to y2, y equal to y2, and z equal to z2. Now there will not be any confusion, and therefore this x coordinate is x2 now because it is eliminated in this direction. This is x1. I am measuring this as x1, so this is going to be x2, and y should be y2 and z2. So now this is what the problem is. Why I am getting these two things? They should not be, right. So this line is parallel to z axis, z equal to some lambda. This plane equation is parallel to yz plane. So x equal to the entire plane should have x equal to x2 throughout. Yes. So this is a plane of x equal to x2. What about y and z? So this side it is, this should have z2, this should have z1. Regarding y coordinate, it is uplifted. All these planes should have same y coordinate. Same y coordinate. That means this should be y1 babu. Okay. Yes. Now it is clear. This is also important to identify all the four vertices. Since origin is not there, that is why so much problem is coming. But if origin is right over here, then it would be very easy. Now this is uplifted in which direction? Y direction. So its y coordinate is going to be y to baki x and z will be same. So this is how you write vertex for this. And coming back to here, it is like this uplifted by y side. So it will have x1, y2, zy. This one. As you can see, this entire plane is actually parallel to xy plane. So z equal to constant throughout this. So that is z equal to z1 plane. And this plane is z equal to z2 plane. Everybody will have z equal to z2. So 1, 2, 3. And this vertex, as you can see, intersection of this plane as well as this plane as well as this plane. So all of these are like, xz, same y, will have same y2. And all of these will have parallel to xy, same z2. And naturally, the x is obviously x2. The x, regarding x coordinate, what is this x? This is x1. Okay, so this should be, this is x2. Is correct. Then how these two will coincide? They are at the same height, so y coordinate should be same y2. Regarding z coordinate, yes, that is the problem. This plane you see should have same z, right? So it is z1 in fact. Then only you get this distance as same as this distance, same as this distance, same as this distance. That is z2 minus z1. So little tedious tasks. The same thing would be much easy if you can fix your origin somewhere here. Okay, so if origin is kept, for example, here, then this edge length is suppose A, then you can directly write A00. That is, you are choosing this as x-axis, and this is y-axis, and this is z-axis. So it is uplifted in y direction. So 0, suppose this length is B, this length is C. 0, B, 0. And this is uplifted in the direction of z-axis, z by C units, so 0, 0, C. And coming back to here, this is like, uplifted in the direction of z-axis A0C and uplifted in the direction of y-axis ABC. So this is a point ABC. And then you have taken that onto the side. This is like uplifted by B units AB0. And this one is uplifted in the direction of B, so 0BC. Okay. So x equal to 0, z equal to 0, y-axis. So that lies on this. And this axis is parallel to y-axis. X equal to 0, but z equal to C. Right? X coordinate is 0 right over here. So that is how you can write 1, 2, 3, 4, 5, 6, 7, 8. All 8 corners. So writing this is also important. Okay. So now since we have distance formula already, so next formula we can talk about is section formula. Suppose there is a point P x1, y1, z1. There is a point Q x2, y2, z2. We want to find any point on this particular line formed by P and Q. So suppose it divides internally in lambda is to 1 ratio, and there is one more point harmonic conjugate R and S. There is another point which divides in the same ratio, lambda is to 1. The thing is R divides internally, internal division. So like you have done there, you can apply the same formula here in 2D. That is lambda into x2 plus x1 by lambda plus 1, lambda into y2 plus y1 by lambda plus 1, lambda into extra component z2 plus 1 by lambda plus 1. Whereas S, which divides in the same ratio, but external division. So that is going to be lambda into x2 minus x1 by lambda minus 1, lambda into y2 minus y1 by lambda minus 1, lambda into z2 minus z1 by lambda minus 1. Okay, so that is the section formula. So midpoint obviously when lambda is 1 in the internal division. How to prove this? You can prove using vectors again. PR bar equal to lambda into PQ bar. Then you will get the coordinates for R. So anyway, we are familiar with section formula in 2D. The same thing we are writing here. So one example could be find ratio in which 2x plus 3y plus 5z equal to 1. See, if I don't write this 2x plus 3y equal to 1 is your line in 2D. Something like ax plus by equal to some k. Now this line, you pile up more lines on the same line in the direction of, coming out of the plane. More lines in the direction of z-axis. Then that will become ax plus by plus cz equal to k, which is known as plane equation. This is a plane equation in 3D. This is a line equation in 2D. So therefore, this is a plane. So I must say this plane divides the join of, say, 1 0 minus 3 and 1 minus 5 and 7. Effectively, what I am asking, there is this plane. Okay, first check that these points are not on the plane. 2 0 1. They are not satisfying, so they don't lie on the plane. Okay, so like if you remember the same question we have done in 2D, 2 points are there, one line is there. The join PQ is divided by line L equal to 0 in what ratio? Minus L11 is to L22, if you remember. Take the point x1, y1, put it in the line, take the point x2, y2. How you have proved this? You assume that let this intersection R, okay, divides PQ in lambda is to 1 ratio, and that lies on this particular line. Same thing we are going to do here. That is, suppose this is a point, say 1 0 minus 3, and this is a point 1 minus 5 7. So there is this line joining PQ, and this plane is basically intersecting this line at the point R. Then you say that the plane divides the join of P and Q in ratio PR is to RQ. Okay, so let us assume PR is to RQ equal to lambda is to 1. Then by internal division, you can assume by default internal division, but lambda, if it comes to be negative, then you understand that it is not more internal division, but it is actually external division. Remember, 3 is to 1 internally is internal point PQ. That lies here. If I say minus 3 is to 1 internally, that actually translates to 3 is to 1 externally. Okay, please understand this. So let the ratio be lambda is to 1. Then R by section formula, you can apply lambda into this plus 1 into this by lambda plus 1, lambda into this plus 1 into this 0 by lambda plus 1, lambda into this 1 into this by lambda plus 1. This is a point R, but since it lies on the plane equation, 2x plus 3y plus 5z equal to 1. Then only you can say that you are dividing this plane. The plane is dividing the line joining PQ in lambda is to 1 ratio. Only when this point lies in that particular plane. Okay, so if it is parallel, it cannot divide. It is as simple as that. So take this point and substitute in the plane. Then you get 2x, 2 lambda plus 2, 3y minus 15 lambda, 5z, 35 lambda minus 15 by lambda plus 1 equal to 1 or equal to lambda plus 1. So you get 2 lambda minus 13 lambda, 22 lambda, 21 lambda equal to 2 minus 13, 14. So lambda equal to 2 by 3. So basically what we are proving is that this plane is dividing this line in ratio 2 by 3 is to 1. That is same as saying 2 is to 3, and it's positive. So definitely what you have assumed, internal division, is correct. When do you think? The same concept is used in the plane to decide whether these 2 points lies on opposite sides of the plane or same side of the plane. Opposite sides of the plane means what? This division should be internal, and what ratio you got lambda, that should be positive. So in a way, this same formula, remember L11, L22 greater than 0 same side, L11, L22 less than 0 opposite side. In the same way, I would call it as, the ratio directly given by the formula if you are interested. The ratio in which plane divides. Pi. Pi is the notation, like L is the notation we use for line. Pi is the general notation to use for plane. Ax plus by plus cz equal to d divides the join of say p x1 y1 z1 q x2 y2 z2 is given by minus L11 by L22 there, and here it is minus pi 11 by pi 22. So that is, take the point and substitute in the plane equation. Okay, by take the second point and substitute in the plane equation. Similarly, you can extend the same condition. If pi 11 pi 22 अगर greater than 0 है, तो इसका मतलब है both the points PQ lies on same side of plane, क्योंकि उस समय लैम्डा आपको नेगेटिव मिलेगा, तो माइनस पाई वन बाई पाई टू नेगेटिव होगा, तो पाई वन वन बाई पाई टू पॉजिटिव होगा, या फिर पाई वन वन पाई टू अगर नेगेटिव हुआ तो इसका मतलब ये है कि EQ lies on opposite side. So same thing we do when we come to planes discussion. So lines and planes we will discuss simultaneously in both vectors and 3D language. Okay. So for example, if you want to apply this in the previous case, the plane given was 2x plus 3y plus 5z minus 1 equal to 0, and the first point given was 1 0 minus 3. Okay, x1 y1 z1. Second point given was 1 minus 5 7, x2 y2 z2. So the ratio in which pi divides pq is directly given by minus of, substitute the first point in this plane, that is 2 plus 0 minus 15 minus 1 y. Substitute the second point in the plane, 2 minus 15 35 minus 1. So that is equal to 1 minus 14 14, 14 by 1 minus 14 21. That is equal to 2 by 3 or 2 is to 3. Right? Next very important discussion, Babu, that is direction cosines and direction ratios of a line. So what is the technical definition and what are these? In short, these are known as DCs and DRs. Suppose in 3D you have a line. Some line is there in space. Suppose this line makes an angle alpha with x-axis, beta with y-axis, and gamma. So you have to visualize gamma with z-axis. Gamma is coming out of the plane, z-axis is coming out of the plane, and that line is making an angle gamma with z-axis. Let alpha, beta, gamma be angles made by any line in space 3D. Space is also written as R cube in IIT EJE notation. R cube means what? R cross R cross R. Real number cross real number cross real number. That means what? It represents a triplet, x comma y comma z. That means you are dealing in 3D. That is what you have to understand. Any line space with say x-axis, y-axis, z-axis respectively. So without loss of generality, let me assume one end as x1, y1, z1. Take any 2 points, for example, on that infinite line. Okay, so definitely I can write PQ bar, that is x2 minus x1 into I cap, y2 minus y1 into j cap, z2 minus z1 into k cap, right? So if you want to find what is your angle made with x-axis, cos alpha, that is nothing but PQ dot vector along unit vector along x-axis I cap by mod I cap, that is nothing but x2 minus x1. Similarly, cos beta by mod pq also is there, right? So mod pq x2 minus x1 by pq, distance between them. So cos beta equal to similarly y2 minus y1 by pq, cos gamma equal to z2 minus z1 by pq. Okay, so the triplet, ordered triplet, cos alpha, cos beta, cos gamma, this triplet is known as direction cosines, direction cosines of the given line. And I'll show you that this vector cos alpha I cap plus cos beta j cap plus cos gamma k cap is unit vector. You know why? Because most important property, cos square alpha plus cos square beta plus cos square gamma, if you look at it, it's going to be this square plus this square plus this square, that is x2 minus x1 whole square by pq square plus y2 minus y1 whole square by pq square plus z2 minus z1 whole square by pq square, that is equal to 1. After all, pq square is the distance between the points. Therefore, what you understand is that whenever you say that this is my direction cosines of the line, it is nothing but a unit vector. Therefore, the DCs are analogous to unit vector in the direction of the line. It is as simple as that, of the line. First thing. Second thing, whenever you say, they are also represented using the notation LMN, standard notation. DCs are also represented by L comma M comma N, where L comma N is exactly equal to cos alpha comma cos beta comma cos gamma, and you know L square plus M square plus N square is nothing but sigma cos square alpha, that is equal to 1. So since they are unit vectors, sum of the squares should be 1 because the magnitude is going to be 1. Okay, so if you are given any 2 points, it's very easy to find, right? So most important property, cos square alpha plus cos square beta plus cos square gamma equal to 1. Convert into sine, then you get sine square alpha plus sine square beta plus sine square gamma is going to be 3 minus 1, that is equal to 2. Okay, so if a line, for example, makes 45 degrees with x-axis, 45 degrees with y-axis, find angle made by line with z-axis. Okay, let us take this question. Then what they have given is that alpha is 45, beta according to our notation is also 45, gamma we need to find. But we know that if any line makes alpha, beta, gamma with x-axis, y-axis, z-axis, the sum of these squares must always be equal to 1. So cos square 45 plus cos square 45 plus cos square gamma equal to 1. And this is 1 by 2, 1 by 2 plus 1, and 1, 1 gone. You get cos gamma is 0. That means gamma equal to 90 degrees. Therefore, line is perpendicular to z-axis. That means that line must be coplanar with x-axis and y-axis. Another question they can ask you is, if line makes equal angles, that is equally inclined, equal angles with x, y, z axis, then what is the meaning of this? Alpha equal to beta equal to gamma. Then you can see cos square alpha plus cos square alpha plus cos square alpha. 3 cos square alpha is 1. Cos alpha can be plus minus 1 by root 3. Why you got plus minus 1 by root 3? 1 by root 3, 1 by root 3. There are 8 octants. You can take parallel lines to one single line. Okay, so therefore 8 unit vectors you can get. Out of them, one which is going out of the plane will have, suppose, 1 by root 3, 1 by root 3, 1 by root 3. Then one going into the plane will have DC as minus 1 by root 3, minus 1 by root 3, minus 1 by root 3. Okay, so these two are very important relation. What do we know about them? First of all, if a line makes an angle alpha with x-axis, beta with y-axis, gamma with z-axis, then cos square alpha plus cos square beta plus cos square gamma is 1, and the triplet cos alpha, cos beta, cos gamma is known as direction cosines of the line, and it is a unit vector. Unit vector. Since you have given it as a unit vector, if I want to, this is the line, for example, and you know that unit vector is represented by cos alpha, cos beta, cos gamma along the direction of this particular line. So any vector parallel to line, if you want to draw, say some a bar, then it can be written as magnitude of that vector into, say, this unit vector n cap, isn't it? So that is, any vector can now be written as parallel to line, of course. Mod a into n cap is nothing but what? Cos alpha I cap plus cos beta j cap plus cos gamma k cap. Now that can be written as mod A into cos alpha, mod A into cos beta, mod A into cos gamma. This is also represented as mod A into L, mod A into M, mod A into N. So what does these represent? These represents the vector components of any line parallel to it. That is, any vector parallel to given line. Any vector parallel to given line. Okay, so that is represented by this. In fact, this mod, as you can see, they are all scalar multiple of same scalar multiple of cos alpha, cos beta, cos gamma, or element. These are known as direction ratios. Direction ratios, because when you take the ratio, they will be in the same ratio as that of DCs. In other words, if DCs are, say, LMN, then the DRs are nothing but scalar multiple. Lambda L, lambda M, lambda N, where lambda is a scalar, which is mod A in this case, for example. But mod A can be anything. So therefore, if somebody gives you DCs, then you can find DRs. Somebody gives you DRs, then you can find DCs. What is important difference between these two? DCs are unit vectors. Unit vectors. But DRs are not unit vector. Need not be unit vector, right? When they are unit vector, they become DC. That's all. And DRs and DCs obviously are parallel to each other. If you write as a vector, parallel vectors. DC is a unit vector. This n cap you have written, no, that is nothing but DC, right? And you write any other vector parallel to them, you can call this as one dr, this as another dr, etc., etc. For an example, find DCs of a line whose drs are 1, 2, 3. Now what we know is that DCs are parallel to dr. So whether you write dr as lambda into dc or dc as lambda into dr, it doesn't matter. Ultimately, you are going to find lambda value. So let us assume dc as lambda into dr. That is lambda, 2 lambda, 3 lambda. Then, but dc is a unit vector. Direction cosines is a unit vector. So you know that this square plus this square plus this square should be 1, 10, 14. So lambda square is 1 by 14. Lambda is plus minus 1 by root 14. Therefore, you can see this is will be 1 by root 14, 2 by root 14, 3 by root 14. Or minus 1 by root 14, minus 2 by root 14, minus 3 by root 14. That is because for a line it will not have any direction. Parallel unit vector can be either like this or like this. So they will be mutually in opposite directions. Either this is the one or this is the one. That is about DC. So if you give me dr, I will find DC. If DCs of a line, DCs are 1 by root 3, okay, uh, root 2 by root 3 comma 0 for a line, then its drs can be assumed as lambda into DC. That is lambda by root 3, lambda into root 2 by root 3 comma 0. To find lambda value, you need to give me something else, right? So that is a connection between dr and DC. So another thing that came to my mind is suppose you take, earlier we discussed the projection of point P1 x1 z1 P2 x2 y2 z2, projection of PQ on x-axis, y-axis and z-axis. This is what we have discussed. X2 minus x1, y2 minus y1, z2 minus z1. They are the projection of PQ on x-axis. Now, if I want to convert them into the planes, projection of PQ bar, okay, on xy plane. XY plane. That is, you draw perpendicular onto XY plane, then the P dash will come down to XY plane with Z equal to 0, and Q dash will come to be again Z equal to 0. So this is the projection, that is P dash Q dash. In which case it is nothing but x2 minus x1 whole square plus y2 minus y1 whole square. Okay. Similarly, projection of PQ on YZ plane, that is nothing but root over y2 minus y1 whole square plus z2 minus z1 whole square. Projection of PQ on xz plane, that is nothing but root over x2 minus x1 whole square and z2 minus z1 whole square. One important result is that if d1, d2, d3 are projections of line segment PQ on xy, yz, zx planes respectively, then what is d1 square plus d2 square plus d3 square? You square and add, you see it is 2 times pq square. Whereas the same projections, if you are taking on x-axis, y-axis, z-axis, that was in the beginning I told you. Yes. So here I could have added that question. So if d1, d2, d3 are projections of line segment PQ, both questions are important. On x-axis, y-z axis implies d1 square plus d2 square plus d3 square equal to pq square. Okay. So okay. Now let us continue with this. As soon as we know that DCs, what are DCs, what are DR. DC is basically given a vector parallel to this vector, any vector parallel to this vector. Suppose this is A bar. You write this as lambda A bar, and this is a unit vector which is A bar by mod A bar. The same analogous applies to 3D also. There is a line, parallel line will have DRs, and there is only one line which is parallel to this and which is a unit vector, that is your DCs. So every other line will have another DR, all are multiples of DCs. This is lambda into DC. Okay, this dr is some lambda dash into dc, etc., etc. So they are basically forming parallel lines. The important aspect is angle between two lines. Now since you know the direction, angle between two lines whose DCs, for example, are L1 M1 N1 and L2 M2 N2. So basically there are two lines and I have given you the DCs, that is N1 cap I have given in the direction of this, N2 cap I have given. So angle between them is nothing but angle between these two lines. So cos theta, that is nothing but N1 cap dot N2 cap by mod N1 cap mod N2 cap. By default, N1 cap is unit vector in the direction of the line, which is nothing but DC. So this is your DC1, this is your DC2. So it is L1 L2 plus M1 M2 plus N1 N2. So very clearly, like we always do, immediately we look for perpendicular lines. So if lines are perpendicular, what is the criteria? Dot product equal to 0 implies L1 L2 plus M1 M2 plus N1 N2 equal to 0. If lines are parallel, then lines are parallel, immediately you can say N2 cap should be lambda times N1 cap, which means L1 by L2 is M1 by M2 equal to N1 by N2. So these two are the important criteria. For all other cases, the cos theta is given by L1 L2 plus M1 M2 plus N1 N2. This is the situation when DCs are given. What about the situation when DRs are given? Okay, that is let ABC is the standard notation to write DRs. A1 B1 C1, A2 B2 C2 are DRs of two lines. Find angle between them. The only difference now is that although these are also parallel to the lines, like earlier we have N1 cap, N2 cap. Now these are not N1 cap, N2 cap. These are also some other vectors parallel to them. Say this is some V1 bar, this is some V2 bar. But the angle between them is still same. So cos theta is equal to V1 dot V2 by mod V1 mod V2. Only difference is that V1 is now not a unit vector, need not be unit vector. A1, B1, C1. This is your V1 direction ratio 1 parallel vector. V2 is A2, B2 and C2 K cap. So V1 dot V2 is A1, A2 plus B1, B2 plus C1, C2 divided by root over A1 square, B1 square, C1 square and A2 square, B2 square, C2 square. Okay, so this is the new formula for the angle between lines. Clearly again, if lines are perpendicular, then naturally cos theta equal to 0, which means the dot product A1 A2 plus B1 B2 plus C1 C2 equal to 0. Okay, so if lines are parallel again, then these two V2 bar should be lambda into V1 bar. Same rule applies, and DRs also in the same proportion. A1 by A2 is B1 by B2 is C1 by C2. Okay. So one interesting point is, suppose I have two lines with me. One line having DC L1, M1, N1 or cos alpha 1, cos beta 1, cos gamma 1. This has second line DCs are given by L2, M2, N2 and you said how to find angle between them. Now I want DCs of angular, internal angular bisector and external angular bisector. Now if you recollect vectors, this is the external angular bisector. Angular bisector, right? So recollect vector, it is like, I have given you N1 cap here, N2 cap here, internal. The clearly internal angular bisector is parallel to N1 cap plus N2 cap. Therefore, unit vector in the direction of internal angular bisector, that is nothing but DCs of internal, very important derivation above, internal angular bisector, that is nothing but divide. N1 cap is nothing but DC1, which is L1 I cap plus M1 J cap plus N1 K cap plus L2 I cap plus M2 J cap plus N2 K cap divided by mod of N1 cap plus N2 cap. Whereas external angular bisector if you want. Now that will be parallel to, is parallel to, as you can see, reverse it, this is minus n1 cap, so n2 cap minus n1 cap. Therefore, if you want to DCs of external angular bisector, then you divide with the magnitude, that is L2 I cap M2 J cap N2 K cap minus L1 I cap M1 J cap minus N1 K cap divided by magnitude of N2 cap minus N1 cap. So in fact, without simplifying, you can directly write internal angular bisector DC is directly given by, you can see L1 plus L2 M1 plus M2 N1 plus N2. The denominator, if you see, mod of N1 cap plus N2 cap, that is root over, if you want to evaluate this is going to be root over this square magnitude square 1, magnitude square 1, 2, angle between them suppose is theta, that is 2 cos theta. So 2 plus 2 cos theta, the 2 into 1 plus cos theta, 2 cos square theta by 2 and under root. So that is 2 cos theta by 2. Whereas if you want to calculate the magnitude of difference, n2 cap minus n1 cap mod, that is 1 plus 1, 2 minus 2 cos theta, that is 2 sine theta by 2. So for internal, you get cos theta by 2, and for external, it is 2 sine theta by 2. Okay, so similarly, external angular bisector DC, very important derivation, means में directly पूछ सकता है. So that is L2 minus L1 by 2 sine theta 2, M2 minus M1 by 2 sine theta by 2, N2 minus N1 by 2 sine theta by 2. Okay, अगर आपको dr चाहिए तो it will just multiply with some scalar lambda, or you can say that drs of internal bisector, we can skip the common denominator also, will be like lambda into L1 plus L2, okay, and lambda into M1 plus M2, lambda into N1 plus N2. Similarly, drs of external angular bisector is again going to be lambda into L2 minus L1, lambda into M2 minus M1, lambda into N2 minus N1. One small example, find angle between two lines whose drs are say 1, 1, minus 1, 2, 0, 3. Then directly you can say cos theta is, this is like A1, B1, C1, A2, B2, C2. Forget about 3D. Take them as two simple vectors, U dot V. The formula is always, U dot V by mod U mod V. Right? This is your U bar, this is your V bar. Even if they are DCs, mod U will be 1, mod V is 1, that's all. So that is going to be 2 minus 3 minus 1 by root 3 into root 13 mod. Since it is angle between two lines, remember there will always be two answers, right? Angle between two lines will be theta as well as 180 minus theta. So if this is acute, for example, this is going to be obtuse and vice versa, right? So there will always be two answers for the angle between two lines, because lines does not have directions like vectors. Okay. Find DCs of a line perpendicular to two given lines whose drs are given by say 1 0 minus 1 2 2 2. It's like playing with 3D and vectors together. So when I give two lines drs, I am giving you one vector parallel to the line, another vector parallel to the line. So this vector is 1 0 minus 1, that is I cap 0 j cap minus k cap, and this vector, this is u, and this vector is 2 I cap, 2 j cap, 2 k cap. I'm talking about disease of a line which is perpendicular to both the given lines. Two given lines. Okay, so line perpendicular to both given lines is translates to, if you take any vector parallel to this line, we need to find, okay, that vector, that is dr's of the line is a vector, is vector, and this vector is perpendicular to both given vectors. Given lines are given vectors because these vectors are nothing but dr's of the lines. So given vectors, given u bar, v bar vectors. And if you recollect there, how can a vector be perpendicular to both the given vectors? That vector must be parallel to u cross v. So dr's are already parallel to DCs. So directly you can say dr's of given line to be found must be u cross v. So simply find the cross product I j k 1 0 minus 1 2 2 2, that is I into 0 plus 2 minus j into 2 plus 2 4 plus k into 2, that is 2 minus 4 and 2. So these are the dr's of the given line. So once dr's are given, what is the dr's of given line? Are line to be found, not given line. So dr's of line perpendicular to given lines is equal to what we got, u cross v 2 minus 4 2. So once we have the dr's, then clearly the dc's of the line are nothing but unit vector in the direction of dr, isn't it? These are the dr's, divided by the magnitude, you get a unit vector in the direction of dr's. dr's. So that is equal to 2 minus 4 2 divided by root over 2 square plus 16 plus 4. Now since it's a line, you can very well write n cap parallel to this unit vector or n cap like this also. So both plus minus are acceptable here. So that is plus minus 2 by 4 4 8 24, 2 by root 24 comma minus 4 by root 24 comma 2 by root 24. So the DCs of given line, basis of line perpendicular to given lines is given by directly either 2 by root 24 minus 4 by root 24, you can further simplify, that's okay, or minus 2 by root 24 plus 4 by root 24 minus 2 by root 24. That's all. Okay.